Water, wind, gas, or some other form of energy potentially hundreds of thousands of miles away was converted to electricity used in our home through a highly complex grid system a fraction of a second ago. But the question is, how does the grid turn various sources of energy into electricity? How complicated is the grid structure and mechanism, and how does it get to us in a fraction of a second? But first, please make sure to subscribe to our YouTube channel. It motivates us to keep posting. Individual generators, transmission lines, electric distribution systems, and consumer usage or load are the four basic components of an electric grid. Coal, natural gas-fired power plants, hydroelectric dams, nuclear power plants, wind turbines, and solar panels are some of the ways used to generate energy. As a consequence of their physical differences, these technologies are utilized and managed differently on the power grid. Certain kinds of power plants, such as coal and nuclear power plants for example, have limited short-term flexibility in modifying their energy production. Ramping up or down their electricity output takes a lengthy period. Other facilities, such as natural gas-fired plants, can be swiftly scaled up and are often utilized to satisfy demand spikes. There is always a reserve margin, a certain amount of backup energy producing capacity available to compensate for forecasting mistakes or unexpected power plant shutdowns at any given moment. Grid operators regularly monitor and manage power demand, supply, reserve margins, and the mix of electricity producing technologies to ensure that everything operates properly. Electric businesses or utilities own energy producers, and they establish acceptable electricity tariffs for their states, which the utilities must follow. Transmission lines are required to transport high-voltage power across large distances and to link sources and consumers of electricity. Overhead power lines and underground power cables are both examples of transmission lines. Although overhead power lines are not insulated and are exposed to weather, they are less costly to install than underground power wires. On the other hand, underground transmission lines are often insulated, built of aluminum alloy, and reinforced with steel. Transmission level voltages are generally 110,000 volts or 110 kilovolts or more, with some transmission lines delivering voltages as high as 765 kilovolts. Because these high voltages are far higher than what you require in your house, once the power reaches end users, another transformer transforms it to a lower voltage before it enters the distribution network. The distribution network is basically a network of wires that are connected to the transmission lines. The transformers are the starting point for these networks, which go to homes, schools, and businesses. The transformer steps down the voltage to 120 volts, which can be used to run all the appliances at home. When power reaches the customer, you can switch on the lights, watch TV, or run your dishwasher, and the transmission grid comes to an end. Everything in our lives results in fluctuating electrical consumption by hour, day, and season, which is why grid management is both hard and crucial to our daily lives. So that is how the grid system functions, starting from generating and conversion of energy to transmission lines, transformers, and finally our homes. But how does electricity come to us in such a short amount of time? It's due to the electricity's high speed. The actual propagation speed depends on the wire size and electrical qualities, such as induction, but it is normally approximately 90% of the speed of light, roughly 270,000 kilometers per second. And that also answers the question of why the voltage is so high in transmission lines. It is to reduce the transmission loss and to increase the speed and reliability of the electricity, enabling the power system to utilize a variety of resources, even if they are situated far away from where the power is required, thanks to the electrical grid. And that is all for today's video. Make sure to like and subscribe to my channel. If you have any suggestions, then comment on the video. Thanks and goodbye.